I hope you're able to hear.
Yes, sir.
Okay. So, yeah, let's get started. Yes. So you're able to see my screen, right? So you're able to see my screen or not?
Yes, sir.
Yes, sir.
So today, our topic of discussion will be the next chapter, that is gravitation. It's the 8th chapter in your textbook. Okay. So write down the heading as chapter 8, gravitation. See, unlike the previous chapter, this is a small chapter and a comparatively simple one also. Okay. So this is the extension of what you have already learned in your 9th standard. If you remember, if at all you remember, in your 9th standard, there was a chapter named gravitation, where you had this chapter and fluid mechanics, that is Archimedes principle and all those things combined together, right? So here our concentration will be, our topic of study will be only about gravitation. So first, so in any chapter, right, before you start, you need to know certain terminologies that are used in that chapter. So the first term that we are going to speak about is, what is gravitation? So what comes to your mind when you talk about gravitation? So till now we would have discussed, right, gravitational force. So what does gravitation actually mean? It is, write it down. It is the force of attraction between any two objects in the universe. So if you're able to say, or if you're able to speak about the force of attraction that is existing between any two objects in that universe, that particular force of attraction is what is called as gravitation. And the second term that we will be using is called gravity. So what is gravity? So gravity is a special case of gravitation. So gravity is a special case of gravitation, that is, if the force of attraction, is between Earth and any object lying on or near its surface. So this is what we call it as gravity. So try to understand, whenever we speak about gravity, here we are trying to talk about Earth. The force that is existing between the Earth and any object which is close to it. Okay. Next. We would have heard the terms like acceleration due to gravity, right? So what do you mean by acceleration due to gravity? So this you know already. We have used it many times. Acceleration due to gravity is given by g, which has a value of 9.8 meter per second square, or it is 10 meter per second square, right? So what do you mean by this acceleration due to gravity? So here, yeah, tell me.
Sir, it is the fall of acceleration of an object in vacuum.
No, it in vacuum means how will you have? Vacuum means what is the force that is trying to pull the object? No.
So is it the speed attained by object with the help of gravity?
No. You cannot use the word.
Sir, acceleration of a body in free fall under the
Yes.
influence of Earth's
Yes.
gravity.
Yes. So we have learned what is called as a free fall, right? So what do you mean by free fall? Or in our kinematics chapter, that is motion in one dimension, we have studied a topic called as, what was the topic we studied? We studied a topic called motion of an object under the influence of gravity, right? So when you talk about free fall, so what do you mean by free fall, guys? So free fall means generally when the object is traveling under the influence of gravity, what is the acceleration with which it is going to move? It will move with the acceleration due to gravity. So if you try to connect all the dots, then we can give a definition to it. Write it down. Acceleration produced in a freely falling object is called acceleration due to gravity. Okay. So this is what we call it as acceleration due to gravity. So you know the symbol and all, it is denoted by the symbol G, and its value is 9.8 meter per second square or 10 meter per second square. This is only close to the surface of Earth. As you keep moving away from the surface of the Earth, this value will also change. But how far we are supposed to move and all those things, we will see it later. As of now, have this point in your mind. Right? So is there any doubt till whatever we discussed till now?
No.
Okay. So I'm proceeding to the next concept. Please. So the next term that we are supposed to know is weight. So weight of an object. Generally, weight is represented by W. So what is weight, guys?
Mass mg.
Mg is right. Mg is what? How did you get that mg actually? How did you know that? See, what is the parameter where mass what is the output that you will get when you multiply mass with acceleration?
Force.
So weight, you're saying it is mg. G is acceleration due to gravity. Then what should weight be? Weight should be a...
It is the force exerted
The
by an
force.
object.
Yes.
Force
So weight
exerted
is... So weight is also a force experienced by whom? In this case, the force experienced by an object, right? But what is the name of that force? It is a gravitational force experienced by an object, right? Gravitational force experienced by an object when it is being pulled towards whom? Towards the center of Earth. Okay. So here we are going to mainly concentrate on Earth. That is why I'm repeating Earth and all. But the same concept can be applied to other planets as well. Okay.
So, surface of Earth, why is it
No,
the center of Earth, sir?
because if you take Earth, if you assume it to be spherical like this, if you assume Earth to be spherical, okay, then what will happen is, if you keep an object on the surface of the Earth, it will experience a force in this direction. In which direction is this force getting directed?
Okay, sir.
That is the reason why we call the force experienced by an object when it is being pulled towards the center of the Earth. So generally, W is given as mg. Okay. So if suppose you keep it here, if the object is here, mass, then mg will act in this direction. So always mg is directed towards the center of the Earth. So obviously it's a vector quantity, all those things you know.
So
Okay.
instead of gravitational, you can say it as the centripetal, no, sir?
No, you cannot call it because centripetal comes only when the object is in circular motion.
Okay, okay, sir.
Here it is not circular motion, it is resting on surface of it. Okay. Next. So combining all these things, what we can do is we can think of a law which is called as Newton's law of gravitation. So this was in the year 1687. Okay. So the statement for this law goes like this. Write it down. Every particle in the universe, there is a universal law. Every particle in the universe attracts every other particle with a force which is directly proportional to whom? To the product of their masses. You would have learned this. And inversely proportional to whom?
The
To
square of the
the,
distance
Square
between
of
them.
distance between them.
that's it, to the square of distance between them. So this is also called as inverse square law. Okay. So I'm repeating it. Every particle in this universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So an important note to be made here is it is applicable only for whom? Point sized objects. It is applicable only for point sized objects. Okay. So observe, if there is an object of mass m1 here, if there is another object of mass m2 here, the distance of separation between their centers is r. Then the force is always attractive. Another important point to be noted is gravitational force is always attractive in nature. If you see every statement that we discussed till now says that it is an attractive force. So F is directly proportional to the product of their masses and inversely proportional to the square of the distance of separation between them. So from this, you can write F is directly proportional to m1 into m2 divided by r square. From this, if you remove the proportionality symbol, what can you conclude?
G.
You can introduce a constant capital G, which is G m1 m2 divided by r square, where this capital G has a value of 6.67 into 10 power minus 11. The unit of it will be Newton meter square per kilogram square. Wait, I will write it again. So G will be 6.67 into 10 power minus 11 Newton meter square per kilograms. Okay. And this G is called as universal gravitational constant. So since it is told universal, it doesn't change from place to place. It is the same everywhere. Okay. So it is 6.67 into 10 power minus 11 Newton meter square per kilogram square in SI unit. In CGS unit, it will be 6.67 into 10 power minus 8 dime centimeter square per gram square. This is in CGS. Okay. Next, we will see the dimensional formula for it. So what will be the dimensional formula of it? So for the dimensional formula of G, can I write dimensional formula of G is equal to dimensional formula of F into dimensional formula of R square divided by dimensional formula of M1 into dimensional formula of M2. So force is given as ML square T minus 2. R square is given as L square divided by M1 into M2 is given as mass square. So this will be M minus 1 MLT minus 2. So this will be L cube and T minus 2. So this is the dimensional formula of G. M minus 1 L3 T minus 2. Okay. So F is equal to G M1 M2 divided by R square. And we have seen what is the dimensional formula of G. Now I'm going to the next point. Write down some important features
Sir, one question, sir.
Sorry?
One question, sir.
Tell me.
Sir, you said the G. So you said G is constant. So you said G is constant, sir.
I didn't get you.
Sir, you said G is constant.
Yes.
So it is constant only from place to place, or will it change for like every or will it change from every time?
What did I write? What did
Will
I
it
write?
change from the time, sir?
It will not. Why will it change? It is independent of time. It is constant.
Okay, sir.
So important features of gravitational force. First, gravitational force between, write it down, two masses is independent of the is independent of the intervening medium. So it is independent of the medium in which you're trying to talk about the gravitational force. That is, if you place two masses in air medium and do the experiment, if you take the same two masses and separate it by the same distance in water, the gravitational force between them will be the same. Okay. Second, mutual gravitational forces between two objects are equal and opposite. That is, they always form action reaction pair. Hence, gravitational forces obey Newton's third law of motion. Please make a note of this point. Okay. Third point. It is a central force. Okay, underline this word. The meaning of central force is it always acts along the line joining both the masses. So it will always act along the line joining both the masses. So this is a very, very important point. We are going to use this concept in problems also.
Sir, one doubt, sir.
Tell me.
Sir, in the third point, you said that force always acts along the line joining both the masses, no, sir?
Yes.
The previous page you drew an rough figure, no, sir, M1, M2 R.
Where?
Here, so, yes, sir, this one, sir. M1, M2 R, yes, sir, this one, sir. Here, where does the force act towards the line joining, sir?
Like this.
Center, sir.
Yes, they will act towards each other.
Okay, sir.
So, wait, I will explain this. So, if this is M1 and this is M2, okay, this is the line joining both the charges, right? So, force has a direction, right? Force has some direction associated with it. So, according to the third point, I'll give you three stages, okay? First scenario, second scenario, and third scenario. So, in which scenario does it show the right way of force experienced by M1?
Third.
Yes. So that is the meaning of central force.
The second point, I have a doubt, sir.
Tell me.
Here, what does neutral gravitational force mean, sir?
I will explain it. I will explain. See, if this is called as the, see, look at the notation that I'm going to use. If this is called as F12, then this is called as F21. Where I'm calling F12 as, listen to it carefully, because The next topic that I'm going to discuss is vector form of gravitational law. At that time, we'll be using it. F12 is the force experienced. Okay, see, look at the way I'm going to write it in active voice and passive voice. Force experienced by one U2 2. Okay, what I'm saying, if 1 2 means force is experienced by one, that is the first particle, due to the second particle. The same F12 can be defined like this also. Look at the way I'm writing. Force exerted by second particle on first particle. Are you guys able to understand this? So force
Yes.
exerted. So both are same. In a similar way, if I have to write what is F21, you can write force experienced by second due to 1 or force exerted by 1 on 2. Okay. These two forces will be acting in such a way that F12 vector will be equal to negative of F21 vector. Or else what would have happened is every particle in this universe will start moving towards each other. So what is the theory saying? So according to Newton's law of gravitation, it is told that every object that has mass will attract every other mass. Right? See, for example, you have a book in front of you and you are sitting in front of it. Your book also has mass, you also have mass, because you are also made up of atoms and all those particles are there. So every particle in your body will also start experiencing a force towards the book, and the book will also experience a force towards you. But if you observe, none of us are moving, right? We are able to be stable. Why is that happening? It is happening only because of the fact that whatever force we are trying to exert on the book which you're seeing, is equal to the force that is exerted by the book on you. That is why in this point it is clearly mentioned stating that they form an action reaction pair. So if suppose you call the force exerted by you on the book as the action, the force exerted by the book on you will be called as the reaction, or the vice versa. So here what is happening? When action reaction pair is going to exist, right? So when both the forces are going to get cancelled, it is nothing but another statement of Newton's third law.
Yes, sir.
Sir, so if we come in contact with any mass object, we will exert
That's what
opposite force, sir.
that's what the statement says. That's what the statement says. See, read the statement clearly. Every particle in the universe attracts every other particle. So that particle should have a mass. That is only required criteria. Okay. So one thing is clear, that force is equal to, we are telling it as G m1 m2 divided by r square. No. When will the force be zero? There are two scenarios where the force can be zero. One is when mass is zero,
Distance is
or the distance is infinite. Okay, infinite doesn't mean very large distance. I'll slowly come to what that point is. Okay, you will understand. Have all these points in mind. I will explain it to you slowly. As of now, I'm going according to the statement that is given. Till here, it is clear, right? No doubt.
Yes.
Okay, we'll proceed. See. So I hope you understood what is central force also. So it is very important. It always acts along the line joining both the masses. That is very, very, very important. Okay. Now, the last point is, can I erase all these things? The last point is, it is conservative in nature. So you know what is conservative, right? So conservative forces are those forces which do zero work in a round trip. So those are called as conservative forces. And I've already proved that gravitational force is conservative in nature. If you remember, I've already proved this. Okay. So these are the 4 important features related to gravitational force that you're supposed to keep in your mind. Okay. Now see, what I'm going to do is, I'm going to discuss about the vector form of gravitational force. Or I'll call it the vector form of law of gravitation. I'll call it like this. Vector form of law of gravitation. Now see. So we have seen F is equal to what? G m1 m2 divided by r square, correct? So G m1 m2 divided by r square. This is called as the scalar form. Now, if I need to write the same thing in vector, why I'm calling it as vector form is because I've written only the magnitude of. See here, I'm calling it as scalar form because only the magnitude of force is written. I never spoke about its direction, right? So here, what I'm going to do in vector form is we are going to speak about the direction as well. So for that, what we are supposed to do is the question. Okay. Now listen. I'm considering a basic coordinate axis. This is x-axis, this is y-axis. Okay. I'm taking 2 particles of mass m1 and m2. Let's say they are separated by a distance r. Okay. So from point O, if I take this as A and this point as B, from point O to A, I will call it as OA vector. From point O to B, I will call it as OB vector. Okay. So let's call this distance as R1 vector and R2 vector, where R1 vector and R2 vector are the position vectors of the point A and B. Okay. So I hope it is clear to this step. They are the position vectors of point A and B. So I'm writing the same thing. Listen. That is the position vector of B. Okay. Now you join these 2 points. So you are going to get AB. Depending on the direction I'm going to put, I can either define it as AB vector or BA vector. Now what we are going to do is we'll define both. For that, observe what I'm going to do. I'm drawing a separate diagram for A and B. So this is R1 vector, this is R2 vector. If I take the arrow mark like this, then this will be AB vector. Right? Now apply triangle of addition and tell me what is AB vector. From triangle law of addition, can I say OA vector plus AB vector is equal to OB vector? Right? What is OA vector, guys? R1 vector plus AB vector is equal to R2 vector. So AB vector, how can I write it as? R2 vector minus R1 vector. Can I write it like this? So this will be how much? So you remember relative velocity concept? If I write VAB, it will be VA minus VB. In a similar way, if I have to call this as relative displacement, how can I write it with one variable? Can I write it as R21 vector?
Yes,
Able to
sir.
understand? So R21 vector is AB vector, right? In a similar way, what would have BA vector been? BA vector is negative of AB vector. That is known from the basics of vectors itself. So minus of R2 vector minus R1 vector, that will be R1 vector minus R2 vector. Guys, am I clear? So R1 vector minus R2 vector is R12 vector. So from here, an important conclusion that we are supposed to make is AB vector is R21 vector, BA vector is R12 vector. Now, having all these things in mind, so if this is M1 and this is M2, what is the name of this force, guys? So what is the name of the force that I have drawn with the arrow mark? F F 1
1, 2.
1 2 vector. So other will be F21 vector,
2, 1.
obviously. So F12 vector, see F12 vector is acting in direction of whom? In direction of AB vector. F21 vector is acting in the direction of BA vector. Is that clear? Now see. Now what I'm going to write is, from the basics of vector, you know that any vector is magnitude of the vector times its unit vector. This I have told many times. Any vector is the magnitude of itself plus direction. So direction of any vector is given by unit vector, right? In a similar way, can I write F vector is equal to magnitude of F vector into F cap into the direction in which it is acting. Now see, can I write F12 vector as magnitude of F12 vector into the direction of F12? Now tell me, guys, what is the direction in which F12 is acting? Is it A to B or B to A?
A to B.
A to B. So the magnitude is known to us G m1 m2 divided by r square, where this distance is r. Okay, G m1 m2 divided by r square into F12 cap is what direction? It is AB vector, or I can write it as AB cap for your understanding. So this will be G m1 m2 divided by r square into what is AB cap, guys? It is R21 cap. Accepted.
Sir,
Sir,
how
could you
is
explain this again, sir?
R21, sir?
Because that is what is written here. No? What is AB vector? AB vector is R21.
Okay, okay.
AB cap will be R21 cap. That's it. So which point you want me to explain, Roman?
The last point, sir. Somewhere F1 to
F12 is magnitude of that vector times its direction. Okay. So that will be G m1 m2 divided by r square into. Are you clear with this AB cap?
Yes, sir. I understood now, sir. I understood now.
Yeah.
Sir, so magnitude of force acting on both objects is equal to G m1 m2 divided by r square.
Yes. Magnitude is same. That's right. Magnitude is same.
So, sir,
Okay.
for any vector, It will be the product of its magnitude and its direction.
And direction is given by unit vector. That is the general rule, not only here, throughout maths and physics, it is the same.
Okay, sir.
Okay. So one more important point is unit vector is magnitude of that vector divided by a vector divided by the magnitude of it. From this, can I do the rearrangement? So what
Yes.
I can do is G m1 m2 divided by r square. R21 cap I can write it as R21 vector divided by magnitude of R21 vector. So magnitude of R21 vector is nothing but R, because R21 is nothing but the distance between A and B. The distance between A and B is R. Okay. So what I can do is it will be G m1 m2 divided by R cube into R21 vector. So here there are two important points to be kept in your mind. When you write it in the vector form, you can write it in two ways. So what is the difference between this step and this step? It is the direction that you have used. If you use a unit vector, the denominator will have r square. If you use the vector itself, the denominator will have r cube. Okay.
Sir, can you say again, sir?
So if you use unit vector, denominator will be r square. If you use the vector itself, then the denominator will be r cube. So look at the denominator, r cube, here it is r square. Because they appear to be the same, but they are not same. Very, very, very minute point.
But both will give the same value, no, sir?
In terms of magnitude, yes.
Okay,
But when
sir.
you have to write it in vector form, it depends on whether you're using unit vector for the direction or you're using the vector itself for the direction. Look at the difference. Now, here I used cap. Here I've used vector. Okay. Similarly, you guys tell me. F21 vector will be what? G m1 m2 divided by r square into r12 cap, or F21 vector will be equal to G m1 m2 divided by r cube into r12 vector.
Sir, can you scroll a little bit down, sir?
Fine. Okay.
Yes.
Okay. This is all about the vector form of law of gravitation. One last subtopic for today is principle of superposition of gravitational forces. Write down principle of superposition of gravitational forces. Okay. So a
So can you go
statement
to
is
the
like,
last bit, sir?
is that fine?
Yes, sir.
Write down. Principle of superposition of gravitational forces. So the statement is, write down guys. Resultant gravitational force acting on a particle resultant gravitational force acting on a particle due to the number of masses is the vector sum of gravitational forces exerted by individual masses on given particle. I'll explain it. First, write it down. Okay. See, till now we were discussing about two masses, right? But there might be systems where you have more than two masses. Like, let's say you have mass m1 here, m2 here, and m3 here. So if you observe the law of gravitation, it is defined when you have two masses in the system. Right? When you have two masses in the system. What if you have more than two masses? Then the statement here says resultant gravitational force acting on whom? Acting on one particle due to the number of masses is the vector sum of the gravitational forces exerted by individual mass on the given particle. Meaning of it, if I want to find out what is the force experienced by M3 due to M1 and M2, then if I calculate the force experienced by M3 as F31. So what is the meaning of this guys? F31 means force experienced by third particle due to the first particle. It will be towards the first particle because it's an attractive force. Similarly, if I'm interested, so I need to find out what is the force that is experienced by 3 due to 2. So this will be how much?
F32.
F32 as a vector. So the resultant of these two will be somewhere over here. So the resultant force F vector is equal to F31 vector plus F32 vector. That is the resultant force experienced by 3. Did you guys understand this? So now you can ask me a question. Is this applicable only when you have three masses? The answer is no. If it is more than two, even if you have infinite number of particles, yes, this principle of superposition will come into existence. Okay. So how we can do that? Let's see. If n particles are present in the system and we need to calculate force experienced by second particle due to the remaining system. See, even without drawing the diagram, how I'm going to write this, we are interested to calculate the force experienced by second. So the resultant force experienced by second is equal to, so it will experience a force due to 1. So I will write F21. Everything should be a vector sum, guys, because that's what the statement says. It's the vector sum of gravitational forces, right? So F21 vector plus, you guys tell me what should be the next term? F, sorry,
2, 3.
it is F23. Don't make a mistake of writing F22. F22 will not exist because it cannot experience force due to itself. So F23 vector, now we can write it F24 vector plus so on, and the second particle will experience a force due to the nth particle. So this will be the principle of superposition. Why you are writing vector is because we need to take the direction also into consideration. Are you guys clear? So this is the mathematical expression for the principle of superposition of all the forces. Am I clear, guys?
So minimum 3 particles can be there and maximum infinity number
Yes.
of particles.
Minimum 3 and maximum it's infinite. Why I'm saying infinite is because sometimes the particles might be arranged in a straight line also. So what they will do is they want to include some geometric progression or arithmetic progression. They will do something and give a list. So at that time it will be useful. Okay, generally for CBSE they don't ask, you need not worry. But for you to know the information, yes, it is minimum 3 and maximum infinite. Okay, is this clear, guys?
Yes,
So
sir.
this is all about principle of superposition. So how to apply this, that we will start in tomorrow's class. Is there any other doubt from today's class?
No, sir.
Okay then, just wait for a minute. Don't